All right, class. Welcome back. Today we're going to look at some more inequalities, which is what we introduced at the beginning of this week. And there'll still be inequalities that have one variable, so I'm calling those single variable. But now we'll look at just some more challenging inequalities to simplify it. So there'll be multi-step to get it so that we have a variable by itself on one side of that inequality. If you're looking at that worksheet that was assigned on Google Classroom, I'm going to just pick a few problems from there and go through those so that you guys are really comfortable with how this works. So let's pick one and get started right away. Let's look at number 3 from that worksheet. So on 3, they give us negative p minus 4p is greater than negative 10. And so I already talked in the last video about how this is a little different than if it were an equation. If it were an equation, let's write it like that, we would be able to get just one answer for p by combining like terms. So negative p minus 4p, well, that's like adding negative 4p, so we would have negative 5p is equal to negative 10, and when we divide by negative 5, we would see that p is equal to positive 2, and that would be the end of the problem for us. We would know there was one answer, one value for p that made that equation true. If we go way back, though, and we turn it into that inequality, change this back to what it was. So negative p minus 4p is greater than negative 10. Here's the situation where we're not going to have just one value for p that makes this inequality true. We're going to have multiple. And so to figure out what those are, we'll try to simplify this to get p by itself on one side of the inequality, and we'll see what we're left with. Just like with the equation, we want to combine like terms, we want to undo multiplication and get p by itself. The difference is it's not going to be equal to one value. So negative p minus 4p, the same thing, that's like adding negative 4p, so we have negative 5p is greater than negative 10. We'll divide both sides by negative 5, and you'll see that p, well, for a second, we'll say is greater than 2. But here's where I want to encourage you to really think about test points, because the other thing we do to show our answers is we put them on a number line. So if I sketch a number line quickly, so now let's pick a value as a test point, because I know no matter what that 2 is going to be a boundary point, and I know it'll be an open circle because it can't be equal to 2, so we don't make it a dark circle to include it. But the thing I want to confirm is whether I go to the left, meaning p is less than 2, or to the right, meaning p is greater than 2. So the easiest test point that I would recommend for a situation like this would be 0. If I pick that test value of 0, and really that's more appropriate for now to call it a test value, the point will come a little later, then when I put that into my original inequality, I'll see that negative 0 minus 4 times 0 is greater than negative 10. Well, negative 0 minus 4 times, but that's all just 0. So I get 0 is greater than negative 10. Because that's negative 10 and not positive, this is true. Which means that I actually want to go over all the values that include that 0 to the left of the point. Those are numbers less than 2, which means I actually need to flip my sign to say p is less than 2. Some of you might recall I mentioned in the last video that always happens when you're dividing by a negative. Same would be true if you multiply both sides by a negative. The reason I'm holding out to do that is just to really emphasize how important it is to think about using a test value like 0 to confirm which way your line should head. So now, if I pick any number less than 2, 0, -1, -5, and plug that in for p, it should make that inequality true, and that's how I know that works. Don't forget your decimal values can also work. So 1.99 would work and make this inequality true. So that's a look at one more complicated inequality. Let's do one more from that worksheet just to make sure we're really seeing how these will work. So if we look next, let's look at number 6. So 6 tells us that -3 minus 6 parentheses 4x plus 6, that's all greater than -111. And so this is where I mentioned that these inequalities today were a little more challenging than the ones previously, because the actual inequality contains more terms, more operations, so that's more to undo as we try to get x by itself. However, it doesn't change. This is just like solving an equation. So this is just like thinking of that inequality as an equal sign, because that's what we start with to get our boundary point. So when I look, it might be tempting to do -3 minus 6 right away, but realize that there's multiplication right there, so we would have to distribute before we do that. It might be better off to just undo some things right away to get this looking simpler. For example, if I add 3 to each side, then I'll just be left with -6 times 4x plus 6 is greater, well, -111 plus 3 will become -108. So now things are looking a little bit simpler. A next step I can do would be to distribute, or if I want to save myself a little bit of work, since I know this is multiplication by everything on the left side, I can undo it by dividing everything on both sides by -6. So here, the opposite of multiplication is division. That just divides to give me a 1. So I get 4x plus 6. I don't need the parentheses anymore. On the right side, -108 divided by -6. Well, 20 is -120. Should be 18 when we do that. Because we divided by a negative, this is a situation where our inequality should flip on us. So instead of now, or being a greater than, it's a less than. So 4x plus 6 is less than 18. I've been waiting in previous examples to show that because we've relied on the test point, but let's go ahead and flip it now if we're getting comfortable with the idea that dividing by a negative flips the sign. And we'll check it at the end with a test value still. All right, to continue to get x by itself, we'll subtract 6 from each side. So we'll see that 4x is less than 12. And then finally, we'll divide each side by 4 to see that x is less than 3. Because that 4 was positive, nothing happens to our inequality when we divide there, so I didn't need to flip any signs. I'll get my number line set up. 0, 2, 4, -2. Alright, so you may have noticed my number lines, I've labeled them differently. They've looked a little different in some of these examples, and that's because truthfully it just needs to be clear where your boundary point value is, and then whether you're including the values less than or greater than that boundary point value when you fill in or shade that line with the arrow. So before I just go ahead and go to the left of 3, let's put that open circle, because again there's no equal to in ours, so it can't include 3. But let's do that test value of 0 again. So if I put 0 into my original inequality, this one might take a little bit more math. So let's jump down to previous page for just or the next page, excuse me, for a second. So if I write that original equation with 0 in it, it'll be negative 3 minus 6 times 4 multiplied by 0 plus 6 is greater than negative 111. And so here you will have to do some math, but we still get a little bit of a simplification. So negative 3 minus 6 will be multiplied by just 6 on the inside, and that has to be greater than negative 111. Well, I have to do my multiplication right here, so I get negative 3 minus 36 is greater than negative 11, or 111. When I turn that into adding a negative, I'll see that negative 39 is greater than negative 111. That's true because in negatives, remember that negative 111 is a lot further from 0 than negative 39 is on the number line. So that is greater than, and that means that we were correct to think that wherever 0 falls includes our answers. So 0's to the left of my boundary point. So that's where I'll shade on the number line. And I know that x must be less than 3. So that's my final solution set for this inequality, all the values less than 3. None of the principles have changed from earlier this week. However, you'll be challenged more algebraically to get the variable by itself in the problems on this worksheet. So please take a look at those. The answer key follows the problem, so you have a way to check your work. If you have any questions, be sure to shoot me those during office hours from 9 to 11, and I'll get you answers right away. All right, guys, good luck.